Hello everyone, my name is Matthew Osterholt, and I'm going to be discussing the processes in which we use to assess dicamba volatilization within our controlled environment settings here at Purdue University, while also describing and investigating the influence of ferrous sulfate within the dicamba spray solution on dicamba volatility. So recent research has indicated that the addition of 0.02 molar concentration of ferrous sulfate within the spray solution can dramatically increase dicamba volatilization. And while having spray solutions reach that 0.02 molar concentration is possible with the addition of certain micronutrient foliar fertilizers, having groundwater ever reach that threshold of iron is quite unrealistic. And since groundwater is commonly used as a herbicide carrier, our objective is to quantify dicamba volatilization from 4 concentrations of ferrous sulfate, ranging from 0.0001 molar concentration, which is equivalent to the amount of iron found in Indiana groundwater, to the 0.02 molar concentration that I described earlier across 3 dicamba formulations, the DGA, the DGA plus VaporGrip, and the BAPMA formulation. And with that, we can get into the materials and methods.
So in order to test our hypothesis, we start by spraying the glass slides within our spray chamber, then transporting the slides to a separate room and placing them within our volatility chambers. The volatility chambers are then transported to our controlled environment room, and they are hooked up to a vacuum that forces unidirectional airflow over the treated slides, where any volatilized dicamba can be captured by the air samplers and the air is exhausted out of the chamber. Then, 48 hours later, the air samplers are extracted for processing. For each sampler, we push the filter material out of the glass housing with a wooden dowel rod and suspended methanol. We then add an internal dicamba standard. We then take all the samplers to a separate facility for quantification using LC-MS.
And now we can get into the results. We'll first take a look at the BAPMA formulation. I'll take a quick second to set up this graph, as the other 2 formulations will be presented in a similar fashion, where we got dicamba concentration going across the y-axis and the ferrous sulfate concentration going across the x-axis, with the letter separation being placed above each bar, and then below that in red being the spray solution pH of each of these respective treatments. And the first thing that we notice for the BAPMA formulation results is that when we add ferrous sulfate to an equivalent rate of iron found in Indiana groundwater, we see no increase in dicamba volatility. However, as we add ferrous sulfate to that spray solution, we increase dicamba volatilization until we get to this 0.02 molar concentration, where we see this decrease in dicamba volatility associated with a strong decrease in spray solution pH. And when we look at the DGA formulation, we see a very similar trend, where whenever we apply ferrous sulfate at an equivalent rate of iron found in groundwater, we see no increase in dicamba volatility. However, as we add ferrous sulfate to that spray solution, we once again see an increase in volatility up until the 0.02 molar concentration, where we once again see a decrease in dicamba volatility associated with a strong decrease in spray solution pH. And then lastly, when we look at the dicamba plus VaporGrip formulation, we once again see a very similar trend, where whenever we add ferrous sulfate at a rate equivalent of iron found in groundwater, we do not increase dicamba volatility. However, as we increase our rate of ferrous sulfate within the spray solution, we tend to get an increase in dicamba volatilization all the way through the 0.02 molar concentration. And with the dicamba plus VaporGrip, it contains a pH buffer that keeps these pHs of all these treatments relatively similar. So in conclusion, I think we can conclude that whenever we apply dicamba with ferrous sulfate equivalent to that of iron found in groundwater, we do not increase our dicamba volatilization. However, we would be very skeptical. We would not recommend adding a foliar fertilizer at a 0.02 molar concentration, because we know we can increase our dicamba volatilization from our DGA plus VaporGrip formulation. And then with our DGA and our BAPMA formulation, we see a decrease in volatility. However, we're worried that the decrease in pH is causing the iron cations to bind with the dicamba anions, forming complexes that are, while they're less readily volatilized, they may be limiting herbicide absorption into weeds and thus reducing herbicide efficacy. So with that, I want to thank you, and I hope you enjoyed.